Hello, everybody. Welcome to this 10 o'clock mountain session of Pinpoint, where we're going to talk about how to process addresses faster than you can blink. We have Adam Charlton. Is your current title Senior Software Developer Extraordinaire?
Senior software developer, but honestly, just we're all developers,
We're
you
all
know?
developers. He's
We're
one
all
of
write
our,
code.
our developers that works with our Street API, US Street API. You've worked with the international a little bit, yeah?
Not so much. I've really
That's
focused
much.
on the US side, the US data, master address list, all that good
Oh,
stuff.
the master address list. That's right. If you don't know about the master address list, we probably should have talked about it more here at Pinpoint, but it's a cool product. All right, so back to speed and whiz bang amazingness that I have come to expect from Adam Charlton. I'll turn the time back over to you.
Well, thank you so much, Andrew. Give me one moment so that I can pull up my presentation here. Hopefully that's
Sure.
coming through all right.
Yep.
And I think we are good. Great. So, like Andrew very helpfully mentioned, I'm doing 400 million addresses by 5 p.m. In testing this, we're working through it. And so let's put this into a little bit more context because 400 million is one of those large numbers that just without context starts to get a little ambiguous. So let's go into the entire US by end of day multiple times. So 200 million is a rough approximation for the number of addresses that we got in the US. So 400 million means we need to go through the entire US twice. Now, this is actually not that uncommon of a scenario, especially for a lot of people who use our services. They just have massive databases of address information that you got to work through. And in a lot of cases, you got to not just validate addresses, but you got to standardize them. You got to make sure that you can, using perhaps one of our products like Smarty CLI, you have multiple different data sets that you got to merge together into a single one. So 400 million is not that all uncommon of a use case. And that just requires every single address in the US multiple times, sometimes triplicate, however many times you need. We got to run them all through. You got until end of day to do it. So let's set the stage here for the problem that we're trying to solve. Like we mentioned, we got 400 million addresses. You got to do it single workday, just an 8-hour time frame there. You don't have any crazy resources available. You don't have like a huge server farm at your disposal. You just got yourself and whatever computer you got available. And of course, you got all of the fantastic resources from Smarty, and we're going to show you how you can do that. Now, here's what we're going to be covering. We're going to go lightly into some no-code options. Especially, we're going to be looking at some of our higher volume no-code options that we have available. I want to make sure to not quite get the sun in my eyes there, coming in just at the wrong angle. We're going to be going over the bulk upload tool and the Smarty CLI. Right now, I want to do a quick plug for the other presentation that's going on by Spencer. He's going over some of our other no-code options like the Google Sheets plugin and the Excel plugin, as well as a couple of others. If the no-code options is really what you're interested in, what you want to focus on, yeah, there's Andrew. He's popping up to give a little bit more of a plug, I think, right?
Yeah, I just don't feel bad if you leave this session right now because that other one seems more interesting. These are recorded. You can watch this one later. If you want to ask questions live, go to that one right now. And with luck, they're sending people over here. They're just different. They're just different ways to do it. And depending on which way you think you're more likely going to be interested in, you should probably go to that session.
This one will, I think, of the two, definitely be the more technical of the session. About the second half of the presentation on, we're going to be doing direct coding. And so we're going to code up some of our own solutions that will be hitting our APIs at absolutely ludicrous rates that I'm sure the ops team will look over at me and wonder what the heck I'm doing over here. But with that, we're going to be doing no code for the first little bit, talk about some of the pros and cons. These are high volume, low code, no code options. And then we're going to be doing coding for the second half. It's not going to be egregious, less than 100 lines of code for the whole thing, but we are going to be delving into some topics like batching and multi-threading. And we'll see where that takes us. Great. So let's start by going over those no code options like I mentioned. The first one that I really want to talk about is our bulk validation tool. This is a tool that we have on the website. I took a quick screen grab of it here. Andrew, if you wouldn't mind, I think that we had a link to this for our website. that you could post into the chat there. But the bulk validation tool is a tool that we have available on our website. You can upload a file that is about 500,000 addresses, I believe is the limit. And it'll go through and it'll just start to chunk through the addresses as fast as it possibly can. Now, some of the big benefits of using an upload tool like that is that it's incredibly easy to use. It requires essentially, you don't have to have any technical knowledge. You don't have to understand how to code or anything like that. Even drag and drop, just if you know where your file is, drop it into the bulk upload tool and we'll handle the rest. All you really need is the internet. You don't even need to download anything. If you can access the web page, then you can use it. And so this is a good option if you want to start validating addresses pretty quickly with no overhead. There are some downsides to using a tool like this, though. Because of some of the limitations of how you have to upload files, we really have a file size limit of those 500,000 addresses, which means to hit that 4 million address, you're going to need to be running this tool 8,000 times in a single day. And the max throughput of that is really what we're looking at is 190 million. So if you're looking to do the whole US once, this is a potential tool that you can use, but it's just fallen a little bit short of that 400 million, what we're looking at. However, because of how easy this tool is to use, it's really drag and drop file, processes on its own, download it when it's done. This is something that is an option I wanted to bring up when we're talking about high volume, high speed use cases. So the second tool, the no code tool that I want to bring up is the Smarty CLI. We also call it Smartylist at some spots on our website and in our documentation. Now, this is a CLI or command line interface. This is a tool that you have to download from our webpage or from our website. You download it onto your computer and you run it. It'll look very much like this. What I have here, this is my own personal terminal session running. It'll go through, it'll scan the file that you have it pointed to. You hit yes, and then it starts to chunk through the addresses at a really fast rate. In my experience, the CLI is, if you don't want to code, it is the absolute fastest option that you have available for a no-code option. However, before we start to talk about some of the specifics of the CLI, we really got to talk about rate limits for a second. A lot of our no-code options that we're talking about in Spencer's webinar, the Excel plugin, the Google Sheets plugin, and others, and even to an extent our bulk upload tool that we have on the website, rate limits aren't something that you will typically have a problem with. When we start getting to the CLI and everything past the CLI, rate limits are something that we're going to have to talk about a little bit. So I want to make really clear that this isn't a sales pitch, but one of the things that we do at Smarty is we have all sorts of different plans of all shapes and sizes to make sure that it suits your business needs. One of those dials that we can twist is the rate limit. So if you're needing faster speeds, you can talk to Smarty and make sure that we get a plan that fits what you're needed. I see Andrew, I don't know if he's getting ready to interject while I'm talking about rate limits here, but I'm going to ignore him and just keep pushing on. So
Thanks, Dad.
So like I mentioned, once we start getting to Smartylist, the tool itself stops being the problem in speed. One of the factors, the theory that we're always talking about is the theory of constraints. You always have to start pointing to the slowest part in your pipeline, and that becomes your limiting issue. No matter how much we speed up the CLI, no matter how many programming pushes that we do, we start running into whatever your constraint is. And so while we're going through some of these like speed metrics, when we're starting to do the code, if you're not getting the same speeds at me, there's 3 things that I really need you to check. And that's going to be your internet connection. If you don't have a fast enough internet connection, it doesn't matter how fast your tool is, there's going to be a limit as you're pushing addresses up and down that sometimes the internet can't handle it. Some of your settings can be really important in making sure that you have good speeds. If you're using features that you don't necessarily need, or if you're not batching, if you're not doing the same match type, things of that nature, you can get slightly different results, enhanced versus invalid, for example. And then finally, the rate limit on your plan. Cool. With that, I just want to make sure, yep, that wasn't a question that just came in. The upside of the Smartylist. Similar to the bulk upload tool, it is incredibly simple. It's a little less easy than the bulk upload because it requires you to go to the website and download it. And for people that aren't quite as technical, it can be a slight bit of a learning curve to pick up to it. That is more than the bulk upload tool. However, unlike the bulk upload tool, there's no limit on file sizes. I'm getting about 20,000 addresses a second at the max speed in my testing. There is a turbo command line option that can help with that. I got to really be careful again and state that rate limit. Again, if you use this option, this is a tool that has the potential to fully go up to your rate limit and then potentially past it. So I just got to throw that out there. With 20,000 addresses a second by end of day, that's putting us at 576 million max address throughput, which is exactly what we're looking for. Yay, we did it. We don't even need to code. We're still going to code, but we don't have to. So here's some of the downsides, though, that we're looking at of using a tool like this. You can't fine-tune your responses. The way that the CLI works is that it reads from a file and it prints to the file. And because the CLI doesn't know exactly what data you need, you're just going to get the entire response printed to the CSV file. If you only care about one or two fields, or maybe even half the fields, doesn't matter. With the CLI, you're getting the whole thing. You're going to have to run a process afterwards to trim that down to what you need. Because the CLI really works from a file in to file out basis, it doesn't work as part of a continuous flow process. It really has a finite start and a finite end. And that makes it a little bit trickier to chain from other processes together. And, I'm hoping that you're not plugging in a 400 million line file into a single process. Really, some of the best practice is going to be to chain together smaller files, similar to the bulk upload, but you don't have quite that same level of constraint. But best practice really would be to have multiple smaller files and then multiple small output files that you can then stitch together later. However, for a no-code option, the Smartylist or the Smarty CLI is definitely going to get you the throughput that you need at the speed that you need. And so by end of the day, more than capable of running the entire US multiple times, which satisfies our constraints. So with that, those are the no-code options that we have. If you have any questions about the no-code options, be sure to put them in chat, specifically the bulk upload or the Smartylist tool. Put them in chat and I'll be sure to answer them as they come up. I'm sure Andrew will ping me if anything comes up. But otherwise, now is when we start to go into the development side of phase where we're going to be able to get up to that same speed as our Smartylist CLI and even surpass it. So with that, let me make sure to stop sharing and we'll get the screen share on my other side going. Andrew pops in.
I am curious, just out of the audience members, how many of you are ready to have your eyes glazed over when Adam shows code? I guess what I'm asking is how many of you are coders out there? Like how many of you are going to find a lot of use in what Adam's about to show? That's the real question. We always have, and I'm going to be honest and a little transparent here. We feel here at Smarty that we're often talking to developers. We're telling developers how to set this up, but when people are thinking that it's time to buy software, it's not often the developers that are doing that research. It's somebody else that's like, hey, you know what? We need to have this thing. And then they come and find Smarty and they go, yeah, that seems like what we want. And then they hand Smarty to the developers and say, good luck, figure it out, right? So I'm curious who here, and I'm seeing a lot of coder here. I prefer code.
I'm seeing a lot of code too. That's quite heartening.
All right,
I see I'm in the company of fellow developers.
And you're in the right place.
Well, Andrew, if you wouldn't mind putting that GitHub link. Um,
Yes, I'll put it in there.
so we are going to be doing a code with me kind of session. However, if you want to follow along, I do have pre-written code that everyone can go to the GitHub and clone down. This is, if you start looking through those spoilers, you'll see by the end of it, we are going to get some truly ludicrous speeds. However, so feel free to download code from that GitHub. I am going to be posting all of the code that we write in this session up to the GitHub as well. So if you're not following along live, if you miss something that I code up, don't worry. This will all be posted as soon as we conclude with this. And there's some helper functions in there that helps explain what we're doing, like just reading from CSV and everything like that. But without further ado, let's go ahead and start sharing. Let me see if I can find the screen that I'm doing. So again, this template, this package is all on the GitHub to get started. I am going to be using the Go programming language. This is our language of choice here at Smarty and my personal preferred favorite language. One of the reasons why I really want to use Go for this presentation, we'll get to that later, but Go has incredible efficiency with multi-threading processes. They're called Go routines. It's very low overhead, very low context switching penalties for being able to switch between different Go routines, which is how you can get very good performance with the Go programming language, especially on server-side processes, which is why we use it here at Smarty, and we can help deliver products with the speeds that we're going to show. But with that, let's go ahead and get started. So the main thing that we're going to be looking for is we're going to be doing this in stages. We're going to start with just a single address flow. We're going to read from an address. We're going to output to an address. I do have some sample code here that just reads from a CSV. It's about 50 lines of code. I do have a packet of sample addresses that we are going to be reading from. This is sample addresses from our website. It is a list of 500 different Wendy's. It's what we use on our website, and I figure I would continue the tradition and use it here. So let's go ahead and get started. So with the application we're going to use, we're going to make heavy use of the Smarty's SDK. It's one of the best ways to get up and running with our Smarty APIs very quickly. So with that, we're going to start making a client. Street.client. That's not what I'm looking for. And we're going to look and we're going to build our US Street API client. So within that, we need to make sure you really need 3 different things for a lookup. You need to make sure that you have your Smarty Auth ID, Smarty Auth token, and then your license. So I'm going to go ahead and build up all of those things. Fire up dot secret key to credential. Now, I personally don't feel comfortable sharing my API keys with all of you on this beautiful webinar, so I'm going to be pulling from my environment variables. And you see it knows me so well.
Just kidding.
What was that there?
I said rude, but also,
You know, Andrew, if you really want to know my secret key auth ID and auth token, you can talk to me later.
oh, okay. There is a question. Is there a .NET SDK?
I believe that there is a .NET SDK for this particular training due to the way that I'm going to be batching and multi-threading. You will have to do things a little bit different to get it working in your .NET environment, but I believe that we do have a .NET SDK. It is all on our public-facing Smarty GitHub. I don't have a direct link to that. Andrew,
I'll get a link.
I can throw you under the bus if you can put a link out to there.
Yep, I'll get it.
Yep, and it knows me so well. The wonderful autocomplete Smarty Auth token. And like I mentioned, there's one more thing that I'm going to be putting in here, and that's with the license that I care about, which again, I'm going to be pulling from my environment variable. Not Smarty licenses, just the Smarty license. And with that, we have built the client. In the .NET and other SDKs, it's going to feel very similar. Now with that, we can start creating our lookups. Now in Go, we have this wonderful thing called channels, which is a very efficient way that we're going to get all of our addresses. This is a tool that just reads from that CSV repeatedly over and over and over. It just returns an address of infinite. It returns infinite addresses that just cycles through those 500 addresses over and over. And now we're just going to channel through it. So for each of our lookups in this channel, we're going to get our client and we're going to call the lookup. And as easy as that, we have a function that in 25 lines of code is good enough to start working through, that just starts working through all of our different addresses, and it's just plugging along. However, we don't have any reporting with it. And so here's where we need to start getting some speed metrics. This is just address one at a time, read in an address, plug it into a lookup, send that address off. And it just does that over and over and over and over. So now let's start getting some of our speed reporting so we can see how fast is this actually. So what we're going to want is the current time is the time.now. We need to have a lookup count. Each time that we send a lookup, we need to make sure that we increment our lookups. And if the time.since, current time, let's say 5 seconds, sure. We can even report that down to 3 seconds. And let's see how fast we're getting. In fact, let's do it at 1 second intervals just so we can really see our time per second. And we will fnt.printf. Yeah, that's not exactly what I'm looking for. Sometimes the autocomplete does real well, and sometimes it goofs around a little bit. For right now, let's just do address count. Sure. And then the addresses per second. And that looks correct. So now we have a reporting metric that sends addresses, and every second it'll stop and say, how many addresses have I done? So let's go ahead and do that. So looking at that, it looks like that we're averaging just single address at a time. We're doing about 14 addresses a second, which is not bad. But I really think that we can get this faster. How much are we at? We're at 1025 right now. We have some more time to get this really, really faster.
I was going to say that's not bad if I'm just sending to my Christmas list.
Yeah, I mean, at 14 addresses a second, we're looking a lot slower than that, 400 million that we're looking at. I'd have to pull up the calculator to see exactly how fast that is. But now here is where we'll start to get really, really fast. We can start multi-threading this really easily. In Go, that is called Go routines. The idea is that across every single channel, across every logical core that we have, we can be sending an address. And while it's waiting for the network, we can just send another address and another one. And then when the first one comes back, we'll process it and send another one. And if we have a bunch of those, even though we're only sending the single address every single time, we'll be able to get tons of speeds because while we're waiting for that network latency, they're all sending addresses. And so let's go ahead and do that. One of the ways that we're going to do that, and this may be cheating a little bit, but we're going to have an additional channel on the front so that we can send addresses into it. We can count how many are going through the system, and then we'll push it out to all of our channels that are processing them. So the way that we're going to do that is by using what's called an anonymous function. So the way to do that is that we are going to be receiving a channel. Let's call it a counter channel. And this is going to be a channel of street.lookups. And let's have the channel size be 10 because we don't need it to be super large. And so we are going to be, for each lookup in our counter channel lookup, we are going to do the exact same that we did here. And we're just going to log it. Now, this can be done multiple times. This is a function that just will infinitely go through this channel and print how many addresses that we have. Let's spin up a couple of instances of it. So let's say 10 channels. So on my computer right now, I have 12 cores. And so let's just bump that number up to 12. So right now we have 12 different threads, Go routines, that are going through and reading from this channel and processing all these addresses. So let's change this around a little bit, where instead of sending the lookups, we are going to be pushing this to our counter channel. And there is one bug that I did that I will swiftly correct. So with that, let's go ahead and give it a shot. Let's see how much faster we can get. Immediately crashed. Great. That's what I love to see. That's because this needs to be a Go routine instead of just a function. This is one of the perils of live coding, right? It doesn't matter how much I've done it all ahead of time. You can see right here all of my beautiful code in pristine elegance, but I'm trying my best to make sure that we're doing this as we would anyone else, and we're just going to go off and start coding.
At
So you
least
can
we
see
know you're
right
not
here, we
faking it.
immediately went from, this 14 addresses seconds, immediately jumped up almost 100x to 142 addresses seconds. Some of these were getting upwards of 191 addresses a second, which is feeling pretty good.
That is good.
But
Good to
we
see
can
failure
get
too,
even
because that
faster.
means you're not just playing a video. This is real.
This is live chat, huh? Yeah. You know it's real when people make mistakes, right?
We love to see mistakes these days.
But with that, we can get even faster. One of the interesting things about multi-threading processes like this is that you can actually have way more threads or Go routines than you have actual cores on your PC. The idea is that whenever you launch a process, you can send an address up and then it becomes blocked. It's a waiting state. So your CPU scheduler can put that on hold until something happens, and it can use that same core to spin up another OS thread and then launch a new process. So I found that on my machine, I can get upwards of about 100 Go routines without any detriment. So immediately, even though I only have 12 CPU cores, we can immediately spin up that number of Go routines to 100. And we're starting to get really in the realm where we're starting to get some pretty good speeds. We're starting to get 1,000 addresses a second, which is not bad. Just making sure. Yeah, I have John Hickey in chat saying that the old speed would take 330 days to process 400 million addresses, which isn't really the point of what we're trying to hit here. But, incremental steps, baby steps here. I wonder, doing the
Well,
math, how
you've
much that
chopped
this
it
is going to
down.
spin
You've
out
chopped
at.
it down quite a bit. The first one was 330 days to process 400 million, and this one's only 24 days. We've already cut it way faster. If you even just cut that in half, it'll still be impressive.
Yeah, at 191, it would take 24 days. I'm excited to see John Hickey, our resident mathematician, apparently, how much it's going to be to spin up when we have 1,500 addresses a second. But this is still rookie numbers. We can get so much better than this. One of the bottleneck that we are now currently running into is the number of logical CPU cores that we have on our computer. And again, I'm not running this from any sort of like ultra high performance, mainframe that we have here at Smarty. I'm literally running this on my laptop. And for this next step, I'm actually a little bit worried that when I spin this up to its full speed, that I'm actually going to utilize all of my internet and the Zoom call is going to drop. So let's pray that doesn't happen. Um, so our bottleneck is now the number of logical cores. However, what we can do is make every single one of those Go routines far more efficient. We have the network latency. We can't really adjust how much time it takes to go from my computer to the server. We can't up the number of cores anymore that we have here. You'll see if you're trying this at home, if you spin this number up to something ludicrous like 500, you'll see that it tries its best. It really starts processing pretty quick. And then very soon, this better fail on me. Yeah, you see, it starts really dropping pretty dramatically because the amount of overhead that it takes to context switch between all of our different routines really starts to catch up with it. And eventually it will just fail. The OS just can't keep up. And it will say, I can't spin up a new thread. I just can't do it anymore. So 100
I
really is
just,
about a peak for
I
what we
just
want to
can't
do.
do it anymore.
Even computers have our limits, right? However, what we can do is on every single lookup, instead of just sending one address, we can send 100 addresses within a single lookup. That makes each individual Go routine or thread far more efficient. It takes basically the same amount of latency because most of the time that it takes per request is actually the travel time it takes to go from your computer to the server and back. The actual time on the server is incredibly quick. So let's go ahead and make that change. So for each lookup, we're going to need to have 100 different lookups. So let's create a batch. Street.batch. Thank you, autocomplete. And now for each lookup, let's go ahead and add this lookup to the batch. Now, if the batch is full, let's go ahead and send the batch. So instead of sending the lookups, let's do client.sendBatch. And then at the end of it, let's wipe the batch. A little bit of an optimization instead of making a new one, just that slight bit of extra efficiency that we want. Let me make sure that everything in here is looking good. We have the batch. We're appending the batch. If the batch is full, we're going to be sending the batch, and then we're going to clear the batch at the end. So with this, we are now sending 100 addresses per Go routine instead of the single one-off addresses that we had before. So let's go ahead and see how fast we can get it. So with this, again, this is just on my laptop. This is not a server or high optimized computer, but we're starting to get around 65,000, 75,000 addresses a second, which, in my modest opinion, isn't bad.
I'm waiting
But
for John Hickey to tell us how many days it would take at that speed now. If we average 70,000, how long would it take us to process 400 million addresses? I mean, that's our goal is 400 million by the end of the day, right?
it is indeed. Now, I know from previous experience, we should be well under that number. Our Smartylist CLI was able to do this much in a single day, but and this is about 3 times faster than what we're running. So I have a calculator pulled up on the other one. So let's pull open 800 million. And let's divide that by our 70,000 addresses per second. So at that speed, it's going to take about 3 hours, which is not bad, honestly. So for something that we were able to knock out in 50 lines of code, we're hitting about 3 hours for 400 million addresses. And I'm waiting for John Hickey to pop up in the chat and tell me that my math is completely screwed up, that I messed up somewhere.
Oh man.
Thank you, John, by the way. I don't know if I've been saying that. But with that, I mean, and you can see on some of the other ones that I have here, this batch and multi-threading flow that I have over here is getting similar speeds. But we have, with just some very short lines of code, less than 100, even right around 50 lines of code, we're able to process all of those addresses, 70,000 addresses a second. Yeah. John Hickey pointed out that apparently my math is incorrect. It'd only take about 1.59 hours. So there we go.
Yeah. Much faster.
I mean, at this point, we are hitting the entire US address system, not just once per day, not just twice, but we're looking at like 6 or 7, you know, oh, I did do 800 million in my math. I don't know where that number came from. I was just trying to, I was trying to lower the bar for everyone so that
That's
when
right.
John
You're being
came in, he
ambitious.
was able to know it's even better than what you expected. But this is really the power of Smarty's API, because at this point, the rate limit that we're running into isn't even like Smarty's API. If I went to Smarty's API, if I could take my computer and I could just multiply my computer running this code across the whole board, we'll be able to get this amount of throughput per computer. Smarty's API is not the bottleneck anymore. It really is the amount of processing space and my internet speed on my computer that is limiting how much I can get through. If you want to start running, we're already running the entire US every hour, but we can do the entire US every 30 minutes. We can do the entire US every 15 minutes if we had more computers running it and you could process those across the board. And so the question at the end of the day is, can you get 400 million a second? Yes, easily. You can use our Smarty CLI, but with just a little bit more work, with a little bit of code backing you up, you can get even more ridiculous speeds where you can start running the entire US, not just by end of day, but by the end of the hour. And with that, I'll make sure that I'm going to post this up to GitHub immediately following this presentation. But I think that is about where we are going to stop the presentation. So I'm going to stop the screen share with the, with the assurance that you will be seeing the code again as soon as I post it up to the GitHub.
Excellent. We did have a question that wasn't necessarily tied to speed, but about how you're setting things up through the API. Let's assume I have a unique identifier of a person's address, one person, but we're going to send to them at multiple addresses. We're going to mail them at home. We're going to mail them at the office. We're going to mail them at their ex-wife's house. I don't know. For a person in bulk validation using the API, would I combine the ID with address type in input ID field? How would any ideas how I might want to do that? If I say I need to send to this list of people and this person has 3 different addresses.
Yeah, there's a couple ways that you can do it. You always need to utilize the input ID. So the input ID field is the reason why we added it is so that our customers can inject their own ID that will flow through the system. So if you're using something like the bulk upload tool, the CLI, or our API in general, you pass in an ID and it will return with that ID. So there's 2 ways that you can utilize it. They both require deduplication. You either have to deduplicate before you send it to us, or you got to deduplicate it after. If you do deduplicate it before, you just say, hey, I have 3 different inputs with the same ID. I just want to pick one and send it. There are some problems with that because you might have picked the one address that doesn't exist. So by far the better way is to deduplicate it afterwards. You send all 3, comes back, you deduplicate on the on the input ID, and just make sure that you pick one that exists. So that's what I would do. There's a lot of tools that do that really well. If you're using something like the bulk upload tool or the CLI, it produces a big file. You can write a script that does that, using Bash like Unique, or you can use other tools like Microsoft Excel to go through and uniquely identify those keys and make sure that you're picking the right one. So that's personally what I would do. If you have 3 different addresses, just make sure that you're sorting on that input ID and you're picking the one where you can actually mail something to your customer.
Excellent. All you coders out there, any other questions about what Adam was just showing? Again, John Hickey's mentioning Smarty Key can help with ID duplicates as well. Do you want to talk a little bit about Smarty Key? I don't think we've talked about.
Yeah, Smarty Key is a very powerful tool for making sure that you can merge different data sets together. So for example, it can say, hey, I have address A that is 121 Main Street with street spelled out. Over here I have 121 Main ST. And Smarty Key is a very easy way of making sure that you can deduplicate without needing to go through the process of checking each individual address component individually. Smarty Key A, Smarty Key B, they're the same Smarty Key, the exact same address. One of the things that it doesn't help with is in the specific situation of needing to mail to someone's business address and someone's home address. We are not in the industry of tracking where you live and where you work and where your ex-wife lives, where you can deliver mail. And so those will show up as different addresses and therefore different smart keys. However, for things where it's the same address, it's just represented in different ways, Smarty Key is an excellent way to provide deduplication.
Excellent. Excellent. I don't show any other questions here. Thank you, Adam. Thanks, everybody, for hanging out with us. Oh, one last question that just came in. I'm glad I caught it. Do we need to whitelist our server to call the API?
The API, it depends on your specific settings that you have within your Smarty account. And a lot of that can go into security-based rate limits or the rate limit of your plan. So I would check your Smarty settings to see if you need to whitelist your server.
Okay, great. Looks like this has been useful. Thanks, Adam, for your time, and thanks everybody for attending. We'll see you in the next session.